Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive guide to cloud computing, building upon a basic overview and then getting our hands dirty with code examples. Cloud computing, a deep dive, continued. Recap: what is cloud computing? Cloud computing, at its core, is the on-demand delivery of computing services including servers, storage, databases, networking, software, analytics, and intelligence over the Internet, the cloud, to offer faster innovation, flexible resources, and economies of scale. You typically pay only for the cloud services you use, helping you lower your operating costs, run your infrastructure more efficiently, and scale as your business needs change. Key characteristics of cloud computing: on-demand self-service. Users can provision computing resources, example servers, storage, without requiring human interaction with the service provider. This is often done via a web portal or API. Broad network access. Cloud capabilities are available over the network and accessed through standard mechanisms, example web browsers, APIs, from a wide variety of client devices. Resource pooling. The provider's computing resources are pooled to serve multiple consumers, using a multi-tenant model, with resources dynamically assigned and reassigned according to demand. Rapid elasticity. Resources can be elastically provisioned and released, in some cases automatically, to scale rapidly outward or inward commensurate with demand. To the consumer, the resources available often appear to be unlimited and can be appropriated in any quantity at any time. Measured service. Cloud systems automatically control and optimize resource use by leveraging a metering capability appropriate to the type of service, example storage, processing, bandwidth, active user accounts. Resource usage can be monitored, controlled, and reported, providing transparency for both the provider and consumer of the utilized service. Cloud service models. 1. Infrastructure as a service, IaaS. Description. You are provided with the fundamental building blocks of computing infrastructure: virtual machines, VMS, storage, networks over the Internet. You manage the operating system, middleware, runtime, data, and applications. The provider manages the hardware, virtualization, and infrastructure. Examples: Amazon EC2, Microsoft Azure Virtual Machines, Google Compute Engine. Benefits. High flexibility and control, suitable for complex infrastructure needs. Use cases. Migrating existing servers to the cloud, building custom infrastructure, creating development/test environments, handling unpredictable workloads. 2. Platform as a service, PaaS. Description. You are provided with a platform, hardware and software tools over the Internet to develop, run, and manage applications without the complexity of managing the underlying infrastructure. You manage the applications and data. The provider manages the operating systems, servers, storage, networking, development tools, database management systems, and more. Examples. AWS Elastic Beanstalk, Google App Engine, Microsoft Azure App Service, Heroku. Benefits. Simplified application development and deployment, reduced operational overhead. Use cases. Developing web applications, mobile backends, APIs, and microservices. 3. Software as a service, SaaS. Description. You are provided with a complete application that is available over the Internet. You simply use the application, the provider manages everything else, including the infrastructure, software, and data. Examples. Salesforce, Google Workspace, Gmail, Docs, Sheets, Microsoft 365, Dropbox. Benefits easy to use, minimal upfront investment, automatic updates and maintenance. Use cases email, CRM, office productivity, collaboration. Cloud deployment models one public cloud description cloud infrastructure is provisioned for open use by the general public. It is owned and managed by a cloud service provider. Examples AWS, Azure, Google Cloud. Benefits scalability, elasticity, pay-as-you-go pricing, minimal management overhead. Suitable for applications with variable workloads, startups, companies that want to avoid capital expenditure on infrastructure. 2. Private cloud description cloud infrastructure is provisioned for exclusive use by a single organization. It can be located on premises, within the organization's data center, or hosted by a third-party provider. Examples OpenStack, VMware vSphere, Eucalyptus. Benefits greater control over security and compliance, customization options, and potential cost savings for consistent workloads. Suitable for organizations with strict security or regulatory requirements, legacy applications that are difficult to migrate to the public cloud, and predictable, high-volume workloads. 3. Hybrid cloud description a composition of two or more distinct cloud infrastructures, private, community, or public, that remain unique entities, but are bound together by standardized or proprietary technology that enables data and application portability, example cloud bursting for load balancing between clouds. Examples using AWS for compute and Azure for storage, or using a private cloud for sensitive data and a public cloud for web applications. Benefits combines the best of both worlds: scalability of the public cloud with the control and security of the private cloud. Suitable for organizations that need to comply with specific regulations, those with a mix of legacy and modern applications, and companies that want to gradually migrate to the cloud. 4. Community cloud description cloud infrastructure is provisioned for exclusive use by a specific community of consumers that have shared concerns, example mission, security requirements, policy, and compliance considerations. It may be owned, managed, and operated by one or more of the organizations in the community, a third party, or some combination of them. Examples cloud for government agencies, cloud for healthcare organizations. Benefits cost savings through resource sharing among community members, improved security and compliance tailored to the community's needs. Suitable for organizations with shared security, compliance, or performance requirements. Benefits of cloud computing cost savings reduced capital expenditure, CapEx, on hardware and infrastructure, pay-as-you-go pricing, and lower operational costs, OpEx. Scalability easily scale resources up or down to meet changing demand. Elasticity automatically adjust resources to match workload fluctuations. Agility rapidly deploy new applications and services. Global reach access to resources in data centers around the world. Reliability redundant infrastructure and disaster recovery capabilities. Security advanced security features and compliance certifications offered by cloud providers, although security is a shared responsibility. Innovation access to cutting-edge technologies and services. Challenges of cloud computing Asterisk security concerns asterisk data breaches, unauthorized access, and compliance risks. Requires a strong security posture and a shared responsibility model with the cloud provider. Asterisk vendor lock-in. Asterisk difficulty in migrating applications and data between cloud providers. Asterisk complexity. Asterisk managing cloud infrastructure and services can be complex, especially for hybrid and multi-cloud environments. Asterisk compliance. Asterisk meeting regulatory requirements in different regions. Asterisk cost management. Asterisk unexpected costs due to inefficient resource utilization. Asterisk downtime. Asterisk service outages and network connectivity issues. Cloud security best practices. Asterisk identity and access management. IAM implements strong authentication, authorization, and access controls. Asterisk data encryption. Asterisk encrypt data at rest and in transit. Asterisk network security. Asterisk use firewalls, intrusion detection / prevention systems, and virtual private clouds, VPCs, to secure network traffic. Asterisk vulnerability management. Asterisk regularly scan for vulnerabilities and apply security patches. Asterisk compliance. Asterisk ensure compliance with relevant regulations and industry standards. Asterisk monitoring and logging. Asterisk monitor cloud resources and log events for security analysis. Asterisk disaster recovery. Asterisk implement disaster recovery plans to protect against data loss and service outages. Asterisk shared responsibility. Asterisk understand the division of security responsibilities between you and the cloud provider. Cloud computing tools and technologies. Asterisk virtualization. Asterisk KVM, Xen, VMware. Asterisk containerization. Asterisk Docker, Kubernetes. Asterisk orchestration. Asterisk Kubernetes, Docker Swarm, AWS ECS, Azure Kubernetes Service, AKS, Google Kubernetes Engine, GKE. Asterisk automation. Asterisk Ansible, Terraform, Chef, Puppet. Asterisk monitoring. Asterisk Prometheus, Grafana, Datadog, CloudWatch, Azure Monitor, Google Cloud Monitoring. Asterisk serverless computing. Asterisk AWS Lambda, Azure Functions, Google Cloud Functions. Asterisk big data. Asterisk Hadoop, Spark, Hive, Pig, Kafka. Asterisk databases. Asterisk MySQL, PostgreSQL, MongoDB, Cassandra, Redis. Asterisk networking. Asterisk virtual private clouds, VPCs, load balancers, content delivery networks, CDNs. Code examples. Asterisk. Let's illustrate some simple cloud interactions using Python. We'll use the Boto3 library for AWS, which is a standard tool for interacting with AWS services. You'll need to install Boto3, pip install Boto3. For Azure, you'd use the Azure SDK for Python. For Google Cloud, the Google Cloud SDK. I'll focus on AWS for conciseness, but the concepts are transferable. Example 1, creating an S3 bucket. Explanation. Asterisk. 1. Import Boto3. Asterisk imports the AWS SDK for Python. 2. Credentials. Asterisk. Crucially, do not hard-code your AWS credentials directly in your code. The best practice is to use IAM roles, if your code runs on an EC2 instance, or to store your credentials in environment variables, or to configure them using the AWS CLI, AWS configure. I provided an example using environment variables. If you configure the AWS CLI, Boto3 will automatically find your credentials. 3. S3 equals Boto3.resource, S3, asterisk creates an S3 resource object. Resource is a higher level interface than client. Specifying the region _ name is essential, especially if it's not the default. The AWS_access_key_ID and AWS_secret_access_key are optional if you have the AWS CLI configured or are using an IAM role. 4 bucket_name equals my unique bucket name asterisk defines the name of the bucket. S3 bucket names must be globally unique across all of AWS. 5 S3.create_bucket asterisk creates the bucket. The create bucket configuration is required to specify the region, other than US East 1. Example 2, uploading a file to S3. Explanation asterisk. 1 S3.bucket, bucket_name, asterisk gets a reference to the S3 bucket you want to use. 2 upload_file, file_path, object_name, asterisk uploads the file from file_path on your local machine to object_name in the S3 bucket. 3 error handling asterisk the try, except block handles potential errors during the upload process. Example 3, launching an EC2 instance, IaaS. Explanation asterisk. 1 EC2 equals boto3.resource, EC2, asterisk creates an EC2 resource object. 2 image_ID equals AMI dash, asterisk specifies the Amazon machine image, AMI, to use. AMIs are templates for your instance. Asterisk important asterisk AMIs are region specific. Find an AMI in the region you're using. Go to the EC2 console and browse AMIs to find a suitable one. 3 instance_type equals t2.micro asterisk specifies the instance type, example t2.micro, t3.medium, m5.large. t2.micro is free tier eligible. 4 key_name equals your key pair asterisk specifies the name of your key pair. Key pairs are used to securely connect to your instance via SSH. Important, you need to create a key pair in the AWS console first and download the .pem file. 5 security_group_ids equals sgxxxxxxxxxxxxxxxxxxxxxx asterisk specifies the security group IDs. Security groups are like virtual firewalls that control inbound and outbound traffic to your instance. Important, create a security group in the AWS console, allowing SSH, port 22, access from your IP address, and HTTPS, access if you are running a web server. 6 ec2.create_instances, asterisk launches the instance. 7 instance.wait_until_running, asterisk waits for the instance to reach the running state. 8 instance.load, asterisk refreshes the instance attributes to get the public IP address. It might take a few seconds for the IP address to become available. Important considerations for the EC2 example asterisk. Asterisk AMI selection asterisk choose an AMI appropriate for your operating system, Linux, Windows, and region. Asterisk key pair asterisk create a key pair in the AWS console and download the .pem file to securely connect to your instance. Store this .pem file securely. Asterisk security group asterisk configure your security group to allow SSH access from your IP address. Consider also allowing HTTP/HTTPS traffic if you're running a web server. Asterisk IAM role asterisk if this code is running on an EC2 instance, the best practice is to attach an IAM role to the instance that grants it permission to launch other EC2 instances. This eliminates the need to store credentials in the code or environment variables. Example 4, simple AWS Lambda function, serverless. Explanation asterisk. 1 Lambda_handler, event, context, asterisk this is the entry point for your Lambda function. The event parameter contains data passed to the function, example from an API gateway request. The context parameter provides information about the invocation, function, and execution environment. To input processing *, the function checks if a name parameter is included in the event data. If so, it uses that name in the greeting. 3. Return value *, the function returns a dictionary containing the status code, 200 for success, and the body, which is a JSON string containing the greeting message. Steps to deploy the Lambda function *. 1. Create the Lambda function in the AWS console *. Go to the AWS Lambda service. Click Create Function. Choose Author from scratch. Give your function a name, example my greeting function. Choose the Python 3.x runtime. Choose an execution role, either create a new role or use an existing role with appropriate permissions. The role needs AWS Lambda Basic Execution Role. Click Create Function. 2. Upload the code *. Copy and paste the Python code into the code editor in the Lambda console. 3. Configure the test event *. Click Test. Configure a test event. Click Test. 4. Invoke the function *tested from the console. You should see the greeting message in the execution results. Example 5, using Azure Functions, serverless. This example is simplified because deploying Azure Functions requires the Azure CLI and Azure account. First, you need to create an Azure Function app in the Azure portal. Once that is created, you will create the function within that function app. Here's the Python code for an HTTP triggered Azure function. Explanation *. 1. Import azure.functions as func * imports the Azure Functions library. 2. Main, req, func.http request, * the function's entry point. The req parameter is an HTTP request object. 3. Getting the name *. It first tries to get the name from the query string, req_params.get, name. If the name isn't in the query string, it tries to get it from the request body, assuming it's JSON. For returning the response *, it returns an HTTP response object with a greeting message or an error message. 5. For local testing, there is a mock HTTP class to test the code. Important notes for serverless examples *. IAM roles / permissions * ensure that your Lambda function, AWS, or function app, Azure, has the necessary permissions to access other AWS or Azure services if required, example read from S3, write to DynamoDB. Triggers * serverless functions can be triggered by various events, such as HTTP requests, events from other AWS / Azure services, S3, DynamoDB, queues, and scheduled events. Statelessness * serverless functions should generally be stateless. If you need to store state, use external services like databases or caches. Cold starts * the first time a serverless function is invoked, there can be a delay known as a cold start as the environment is initialized. Subsequent invocations are usually faster. Cost optimization * serverless functions are built based on execution time and the number of invocations. Optimize your code for performance to reduce costs. Next steps experiment * try modifying the code examples to launch different instance types, upload files to different S3 buckets, and create Lambda functions with different triggers. Explore the AWS/Azure/GCP documentation * dive into the official documentation for the cloud providers you're interested in. Build a real-world application. Start building a more complex application using cloud services. Consider a web application, a mobile backend, or a data processing pipeline. Security. Always prioritize security when working with cloud services. Implement strong authentication, authorization, and encryption. This detailed overview and the accompanying code examples provide a solid foundation for understanding and using cloud computing technologies. Remember to prioritize security, cost optimization, and best practices as you explore the vast landscape of cloud services. Good luck, and happy clouding!